the uh, the mechanisms, machines, and then velocity acceleration, or in general, I would say analysis of planar mechanism. Okay, all the velocity acceleration and force analysis, right? Everything we have studied. Today's session, we will focus or dedicate to the gear and gear trains topic. Okay, we'll start the problems of gear and gear train. We'll understand what are the different possibilities. Okay, from the from this area of gear and gear train. Okay, so before we jump into the actual problem solving, just to recall what we have studied in these two chapters. In gears chapter, you remember, um, we first understood or basically there are two parts. One is the gears and another one is the gear trains. Okay, in gears we understood the basics, like I would say types of gears, their comparison based on the if shafts are parallel, intersecting, or non-intersecting, non-parallel. Then another thing which we studied in this topic is or yeah, yes, is the terminology, most important terminology. Okay, so our major focus was understanding the different types and the gear terminology. Okay, in detail. Lob gearing, other things are there. I'll not go into the small details like path of contact, arc of contact, all those formula. Yeah, I'll call it as a gear terminology. Okay, so main is the gear terminology aspect of it, circular pitch, what is module, diametral pitch, and all those things. Okay, backlash, undercutting, so on. Different types of profile, cycloidal, involute, their comparison, and all we have studied in this. Correct. We can categorize it as a gear terminology. Okay. The next, uh, after the gears topic, we studied the gear trains topic, gear trains. And in gear trains topic, we focused um, or we studied the the aspects of different types of gear trains. Okay, and yeah, the first was a simple gear train. Okay. The next one is the compound gear train. Okay, reverted gear train. And the last one is the EP cyclic. Okay. So these are the different types of gear trains, I would say, we have studied. Okay. And yeah, now it's time to understand the problems on it. Okay, so yeah, we'll study it both together. Okay, we'll not like separate it first as a gear stop problems and then gear trains problem. No, we will one by one we will discuss it. Okay, so let's go to the next slide and we'll start the problems. Some of the theoretical questions, some questions, majority of the questions will focus mainly on the numerical questions. But yeah, if some theoretical questions also we'll discuss in between. Um, so yes, let's take the first question. If the number of teeth on the wheel rotating at 300 rpm is 90, then the number of teeth on the mating pinion rotating at 1500 rpm is okay. So basically we are trying to focus on the questions which we have not studied last time. Okay, we have solved some questions while studying this chapter, but now we are focusing on the different questions. Okay, so if the number of teeth on the wheel rotating at 300 rpm is 90, then the number of teeth on the mating pinion rotating at 1500 rpm. Very simple question. So we have a pinion and gear, or pinion and the wheel. uh, yeah mm, so pinion is the one which is generally the driving gear, right? And the smaller one. So of course the answer has to be less than the 30, less than the 90. All the options are less than 90. So yeah, you have to find it. So let's say we have a gear which is running at N1 300 rpm and T1 90, and the second one is pinion. We can call it as a wheel or gear. Okay, pinion. We have a pinion which is rotating at N2. We we know it is rotating at 1500, but T2 is unknown. Okay, you know number of teeth are inversely proportional to the speed. Bigger the rotor, bigger the diameter. Or sorry, bigger the you can say wheel, or bigger the gear, number of teeth will be more. Okay, speed will be less. So N1 by N2 is equal to T2 by T1. This implies N1 is 300, N2 is 1500, T2 is, we don't know, T1 is 90. Okay, so this implies T2 is equal to 300 into 90 divided by 1500. So these two will get cancelled. 3 ones are, if 5 are, we'll get is 18. Okay, so this implies number of teeth on the pinion are 18. Okay, okay, one more question we have, theoretical question. Is the pressure angle of the spur gear normally varies from? So, any guesses? Pressure angle of spur gear. Yeah, this is generally varying from 20 to 25 degrees, remember. So the options are like 14 to 20, 20 to 25, 30 to 36, 40 degree to 50 degrees. Okay, remember, um, 20 to 25 degrees is the um, range of the pressure angle for the spur gear. Okay, I'll give one more question, theoretical question. An imaginary circle. We talked about it. Okay, imaginary circle, which by pure rolling motion, gives the same motion as that of the actual gears is. Can you tell me answer for this? Maybe if you want, I can give you the options like addendum circle, dedendum circle, base circle, pitch circle. So this is the hint to you. Addendum circle, base circle, pitch circle, and the dedendum circle. Which of these options is correct? If I say this is an imaginary circle which by pure rolling motion gives the same motion as that of the actual gears. Any guesses? It's very easy. We have also discussed about it. Pitch circle is the correct answer in this case. Okay. Final answer is pitch circle. Why? I'll explain you in detail. Um, so if you remember, we talked about the gear. So before gear, what the purpose of gear is to transfer the shaft, transfer the basically the motion from one shaft to the another, right? And let's say if we have one shaft and this is another shaft. Now, if I consider the pure rolling motion in between them without slipping, pure rolling motion means there is no slip in between these two pitch cylinders, okay? And yeah, the cross section of it will be the pitch circles. So then basically there is no need to make the teeth, okay? If there is a pure rolling motion, then there is no need to keep the teeth in both pinion and gear, right? Or in this pair. But in reality, we know that this motion, if I try to rotate this wheel, there will not be a pure rolling motion. There will be a rolling motion and there will be a slip also. Okay, sliding. Okay, slip will occur in between them. So we cannot transfer the motion from one shaft to the another shaft like 100%, right? So there is basically a loss. And to avoid that, we make a gear teeth so that the teeth will engage in between each other, and by positive displacement will transfer the motion from the one shaft to the another shaft. Okay, and that's the thing. So hence we can say that the um, we can say that this the answer will be pitch circle, because these are the pitch cylinders and cross section of this pitch cylinder is the pitch circle. Okay, I'll go to the next slide. Next question. Okay, another question is minimum number of teeth for involute rack and pinion arrangement for pressure angle of 20 degrees is. Okay. Okay. So minimum number of teeth. There is a formula. Um, T minimum is equal to 2AR divided by sin square phi. Okay. I'll explain this detail in detail. Phi is your pressure angle. AR is your addendum, which is generally one module. Okay. Um, so and T minimum is minimum number of tests to avoid the interference, and that is what will come into the involute, because in cycloidal profile there is no interference, because cycloidal tooths are like something like this. Okay. Okay, like this. So there is a space here. Okay. um, Minimum number of teeth to avoid interference. Okay. So 2 ER is 1 divided by sin square 20 is, you'll get it as 18 as answer. Okay, 18 is the final answer in this case. Okay, I'll go to the next question. Okay, another question. What is meter gear? MITRE, meter gear. Okay, I'll not write down the options. Meter gear is per gear with a gear ratio 1:1. No. Skew gear with a non-parallel and non-intersecting shaft. No. Bevel gear transmitting power more than or less than 90 degree. No. But what is meter? Last option is which is correct. That is bevel gears in which the angle between the axis is exactly 90 degrees. Okay, so one gear and okay, exactly 90 degree, and speed ratio is 1:1. Means basically their size is also same. Okay, let's try to draw it. Okay, so one of the gear is driving, another one is driven. Okay, so this is how the setup will look like. Okay, very easy question. I'll go to the next slide. Let's take another numerical question. Consider the following statement. following statements. A opinion of 14.5 degrees pressure angle and 48 involute teeth has a pitch circle diameter has a pitch circle diameter of 28.8 centimeter. Then it has options module of 6 millimeter. Which of these options are correct? Okay, multiple. Um, which of the statements are correct? You have to choose. Statement number one is module is 6 millimeter. Statement number two is circular pitch of 18 millimeter. Circular pitch of 18 millimeter. Addendum of 6 millimeter. And the last statement is diametral pitch of 11 by 113. Okay, try to solve this. Which of the following statements are correct? Okay, not that difficult. Yes. So number of teeth are 48. Diameter 28.8, which is 28.28 centimeters, which is 0.288 millimeter. Oh, sorry, meter. Pressure angle phi 14.5. So what is module? Module is equal to diameter divided by number of teeth. 28.8 divided by 48. How much? 6 into 10 raised to the power minus 3 meter. This is 6 millimeter. Correct. First option is correct. Module is 6 millimeter. What about the second? Circular pitch of 18 minutes. What is circular pitch formula? Circular pitch is equal to pi d by t, or you can also write it as a pi m. So pi multiply by 6 millimeter. You know pi is 3 point something and 3.14, and basically multiply by 6 gives you 18 point something. So 18.84 millimeter is the correct answer. Okay. Um, the Okay, so it is 18. So this is, I will say, incorrect. It's not exactly matching 18.84. Uh, Addendum. Okay, so this is the first thing I would say. This is the second thing. Third thing is addendum. What is addendum? You know, addendum is one module. Addendum is generally one module. So, and one module is already 6 millimeter. So it is 1 times 6 millimeter. That is 6 millimeter. Okay, so this is also a correct statement. And what is diametral pitch? Diametral pitch. Diametral pitch is d by d. Okay, just a reciprocal of the module. Module is equal to d by t. Circular pitch is t by d, which is 48 divided by 28.8. Okay. And yes, this is something. Let me check it. Um, Number of tits. Yeah, I think this is not matching with what they have given, right? So correct. This is also a wrong option. Okay, so I would say this is also a wrong option. So the correct statement out of this is the statement number one, which is module is equal to 6 mm, and yeah, the another one is the about the addendum. Okay. Okay. So remember always addendum of a circle is one module, and addendum is, I think, yeah, I forgot, but I remember giving you the formula. It is 1 point something, right? Times the module. Yeah. So yeah, you can go back and check, and if they also ask addendum, you should be able to answer it. Okay. I think it is 1.25 if I remember correctly, but yeah, you can double check. 1.25 times module. Okay, the formula for addendum of a gear is 1.25 times module. Okay, write it down. I'll go to the next slide. Let me check if I have any other question. Yes. Addendum of a standard 20-degree full depth spur gear is 5 millimeter. Stop. If it is to be made as stub wheel, its dedendum must be. Okay. So yes, this is the calculation of the dedendum. For stub tooth, remember for stub tooth, addendum is 0.8 module and dedendum is equal to 1 module. Okay, this is something new. Write it down. Um, the They have clearly mentioned that this is a stub tooth gear. So, what is stub tooth gear? Stub tooth gear is a gear with teeth that are shorter than the full depth teeth. Shorter than the full depth. Okay, and that's why your addendum and addendum will be different. Um, so this is the main when we do the step tooth. Yeah, there is basically reduction. Okay, or in the length of the or in the full depth of the gear. Okay, note it down, and this is also important. Sometimes they may. This is basically the yeah. It's not a numerical question, but this is something you should know. Theoretical one. Okay, I'll go to the next slide. Some of the questions now we'll take it from the gear trains. Okay, a few of them you have already solved last time, but I'll try to take a new ones which we are not studied that time. Okay, so um, write down a question: a compound gear train consisting of spur, bevel, and spiral gears. Okay, as shown in below. Okay. Um, okay. Overall speed ratio of the train is okay. So this is the another. Okay, let me try to draw the figure. Okay, so yes, so this is the overall arrangement. Um, and yeah, I will write it down the number of tens again as the wheel. Okay, so 20, 40, 35, 70, 25, and 50. Okay, this is the overall arrangement. A little bit tricky problem. So we have this arrangement, a compound gear, but they have clearly mentioned it's a compound gear train. We know the compound gear train when they say it's a compound gear train. It is not just initial gear and the last gear. Okay, all the intermediate gears also will impact or will have the influence, right? The on the speed ratio. So write down speed ratio is equal to n1 by n6. Okay, and the first gear has opposite motion or opposite direction as that of second. So that's why the negative sign will be there, right? Since even number of gears are there. Okay, so it is minus minus, I would say, T2 into T4 into T6 divided by T1 into T3 into T5. Okay, so how much? 40 um, into 70 into 50. 40 into 70 into 50 divided by 20 into 35 into 25. Okay, so finally we'll end up with 8 as the answer, 8 by 1. Okay, the final answer in this case is 8 by 1, and 1 by 6 is equal to 8. Okay, the options were like 8, 2, 1 by 2, 1 by 8. Okay, so option A is correct, which is 8. Okay, I'll go to the next slide. Give you another question. The gear train that connects the gear train that connects the hour hand, okay, the hour hand and minute hand in a clock mechanism is in a clock mechanism is okay. So this is the question. The options are like reverted gear train with a velocity ratio so and so, compound gear train with a velocity ratio so and so, EP cyclic gear train with a velocity ratio so and none of the above. Okay. Um, yeah. Or you can consider the last option as a simple gear train with a velocity ratio so and so. Okay. We know that there is a reverted gear train. Okay. So the gear train that connects our hand and the minute hand is the reverted train. We know reverted gear train. Okay, because you are yeah, every the axis is same, right? Minute axis um, for the minute hand, hour hand, we have the same axis. So in reverted gear, this has to be reverted gear train. Now, just tell me what is the velocity ratio? Okay, half of the answer I have given. Um, Now the question is the gear train that connects the hour hand, minutes, hour hand, and sorry, hour hand and minute hand, and here, and minute hand in a clock mechanism is. Okay, try to solve this one. Not that difficult. Okay, let's try to solve this. Okay. So give me 1 minute. Sorry. Mm, The answer for this is 1 by 12. Let me explain how. For 1 hour, if you say our hand will rotate. So for, I would say, for every 360-degree rotation of minute hand for 1 hour, our hand rotates 30 degree, correct? Our hand will rotate at a 30 degrees. Look at this. 12, 1, 2, 3, 6, 7, 8, 9, 10, and 11. So this is the our hand. This is the 90-degree angle. Okay, this is a 30-degree angle, right? So if I say 1 hour means 30 degree. So our hand will rotate 30 degree, and minute hand and rotate at 360 degree, correct? Minute hand will rotate 360 degree. So this is degree only. So the velocity ratio is 30 by 360 is 1 by 12. Okay? So the correct answer in this case is the reverted gear train with the velocity ratio of 1 by 12. Okay. Um, yes, reverted gear train is nothing but a compound gear train. What we saw, speed ratio is n1 by n6. Okay, that is driving by driven. Um, yeah, I think yes. So, but remember the train value if something they ask, it is opposite of the ratio what we are taking. Okay, I'll go to the next slide. Okay, just to give me 1 minute. Yes, so we have gear train, which is shown in the figure. Mm, Gear number 1, gear 2, gear 3, gear 4. 20 teeth, 40 teeth, 30 teeth, and 60. 1, 2, 3, 4. Okay, these are the options. For the gear train shown in this figure, the velocity of the wheel 2 when 4 rotates at a 120 rpm. So 4 is rotating 120 rpm counterclockwise. What is the velocity of the this one? So you have to calculate the rpm and counterclockwise or clockwise. Okay, so this is the question. Okay, maybe you will take this as a homework. Okay, this or we can also solve it if you want, but this is very easy. It's a simple gear train. We can clearly see on each and every gear we have only one um, shaft. Okay, on one shaft we have only one gear, so it's a simple gear train. Or if you want, we can also solve it. So let's try to solve this. And next one I'll give you for the homework. So I'll repeat the question. If gear 4 rotates at 120 rpm in counterclockwise direction, the velocity of the gear 2 will is. Okay, gear 2 is. So if this is counterclockwise, this has to be clockwise, correct? If this is clockwise, this has to be counterclockwise. And if this is counterclockwise, this has to be clockwise, right? This is how it works. So the answer for this is counterclockwise for sure. So let's say there are four options, out of which two are clockwise, two are counterclockwise. The clockwise options are gone. Now it's only the counterclockwise. So they have given 120 and 180. First of all, um, if this is 60, what is the velocity of this? Let's back calculate. What is the velocity of gear 3? Gear 3 will be clockwise, and at what speed it will rotate? If this is 120, this has to rotate at 240, correct? Right? Because it will be, how to say, since it is smaller gear, okay. If this is 60, this has to rotate at a higher speed. Okay, this is rotating at 120 rpm. This should be double because you can say that n4 by n1 is equal to t1 by t3. So sorry, n4 by n3. N4 by n3 is equal to t3 by t4. Like this we can write. So this implies n3 will be equal to n4 into t4 by t3. So n4 is 120, t4 number of tests on 4 gear is 60, t3 is 30, so it is 240. Same way I can say that n3 by n2 has to be equal to t2 by t3. So this implies n2 has to be written as n3 into t3 by t2. So n3 is 240, t3 is 30, um, t2 is 40. So 4 ones are 660, right? Sorry, 6, and that is 180. So the correct answer is 180 rpm counterclockwise. Okay, so for anything you can, even they ask it for gear number 1, what will be the answer? Can you tell me? Gear 1 is first of all clockwise, and the same thing you will do n2 by n1 is equal to t1 by t2. This implies n1 is equal to n2 t2 by t1. This implies n2 is how much? 180, t2 is 40, t1 is 20. Okay, 360 rpm. Okay, so like this you can solve. In this case, the question was mainly this. So about the gear 2. So answer is 180 rpm counterclockwise. Okay, 180 rpm counterclockwise is the correct answer in this case. So if it is simple gear train, do not panic. It's very easy to solve. Okay, I'll proceed to the next slide. Another question, and this is for homework. Again on a simple gear train. Okay. Take a question. In a simple gear train shown in the figure, in a simple gear train shown in the figure, the absolute speeds of different wheels, absolute speeds of different wheels when wheel 4 is the driver. Okay, so we have a wheel 1, okay, wheel 2, wheel 3, wheel 4. Okay, so it is 20 teeth, 40 teeth, 30 teeth, and 60 teeth. Okay, these are the four um, gears we have. N1 is the speed of wheel 1, N2 is the speed of wheel 2, and N3 is the speed of wheel 3, and N4 is the speed of wheel 4. So I'll also write here. I'll say N1, N2, N3, and N4. Okay. The options which they have given are like N4 is less than N2. Sorry, N4 is greater than N2 is greater than N3 is greater than N1, and N4 is less than N2 is less than N3 is less than N1. N4 is greater than N2 is less than N3 is greater than N1. N4 is less than N2. N3 is less than N1. Okay, so this one you can try. Um, the correct option is option B here. That is N4 is less than N2 is less than N3 is less than N1. Okay. Another question again on the similar topic which we have studied just now about the clock mechanism. Quickly, I'll give the gear train that connects the minutes hand and second hand in a clock mechanism. It's okay. I'll not give you the option. Now it is very easy question. I want you to tell me first of all whether it's a compound gear train, reverted gear train, cycloidal, or simple. It's a which one? Reverted gear train, right? If it is clock, it is a reverted gear train. Always choose option with a reverted gear train. If only one option is there with a reverted gear train and other are like compound, cycloidal, and simple, just directly take it. Okay, you don't have to worry. Um, but if there are multiple options with the gear reverted gear train, then you have to find the appropriate options. Like, what is the velocity ratio? They will say reverted gear train with a velocity ratio 1 by 60. Gear, mm, yeah, reverted gear train with a velocity ratio 1 by 720, and so on. Okay, so I would say for 1 minute, if you focus, minute hand rotates how much? 6 degrees only. Okay, because for 5 minutes it rotates 30 degrees. Okay, let me show you. Let's say this is a clock. 12, 1, 2, and 3. Here to here, this is your 5 minutes, right? When, let's say, minute clock moves from 12 to 1, this is 30-degree angle. So 30 by 5, 30 degrees corresponds to 5 minutes. This implies 1 minute, 6 degrees corresponding to 1 minute. Okay, so for 1 minute, minute hand rotates 6 degrees, and second hand rotates 360 degrees. Okay, this implies velocity ratio is equal to 6 by 360, which is 1 by 60. Okay, so the correct answer is the gear train that connects the minute hand and the second hand in a clock mechanism is nothing but a reverted gear train. Okay, is nothing but a reverted gear train with a velocity ratio of 1 by 60. Okay. Okay, let me go to the next slide. Just give me 1 minute. Okay, let's take a question. So in a gear train, the input and in a gear train, the input and output shafts are coaxial. Okay, are coaxial. Gear A with a 20 number of teeth. Okay, gear is 20 number of teeth and is an input gear. And gear D, 40th, is an is on the output shaft. Is on the output shaft. Okay, gear B, 40th, and C, 20th are compounded and in mesh with are compounded and in mesh with A and D respectively. The ratio of velocity of gear D to gear A is the ratio of velocity of gear D to gear A is. Okay, try to solve this one. So yes, it is very simple. It's a reverted gear train problem. We have a gear A, okay, to which gear B is connected, and then we have C gear, and then we have gear D. Okay, so this is a reverted gear train. This is the input shaft. This is an output shaft. Okay, remember the center distance is remaining unchanged. Gear A has 20 digits. Gear D has 40. This has 20, and this has 40. Okay, this is, let's say, the given data. Then of course the ratio, velocity ratio, ND by NA, velocity of the driven gear, that of driving gear, is a reverted gear train is what? A compound gear train. So whatever formula you apply for the compound gear train, you have to apply here and just write. Okay. Okay. It's a TA TC, because gear number A is this, and gear number C, gear A and C are the driving ones, and gear B and C are the driven ones. Okay, so it is TB. Sorry, B and D are the driven ones. Okay, A and C are the driving, and B and D are the driven. So 20 multiplied by 20 divided by 40 into 40, which is 1 by 4, which is 0.25. Okay, it's very um, easy solution. Sometimes they don't give you the figure. Okay, so even though figure is not given, it's no need to panic. This is very easy question if you understand and able to draw it. Reverted gear train concept is clear to you that if it is a reverted gear train, then the input shaft and the output shaft is a coaxial, and reverted gear train is basically a compound gear train, right? Okay, and the center distance between the gear number A and B has to be equal to C and D. If these basic things are clear, you can solve any problem on the reverted gear train. Okay, another question. Here also they are not given the figure. But yeah, you have to imagine it and solve. Little bit bigger question. I'll write it quickly and then let's solve it. In a regular sun and planet type cycloidal gear, the planet completes 5 revolutions. Planet completes 5 revolutions for every 1 revolution of the sun gear. For every 1 revolution of the sun gear, gear. When arm is stationary, okay, when arm is stationary, full stop. Okay, when arm is, if the arm completes 2 revolutions, the arm completes 2 revolutions. Okay, if arm completes 2 revolutions about the axis of fixed sun gear, about the axis of fixed sun gear, the number of revolutions made, the number of revolutions made by the planet gear about its own axis is about its own axis is. Okay, try to solve this one. This is a regular sun planet type cycloidal gear. Okay, try to imagine the figure. This is sorry, sun, planet, and we have an arm. Okay, first problem on the EP cyclic gear train. We have solved significant number of problems last time, but yes, this is again so we in a regular sun planet type cycloidal gear, the planet completes 5 revolutions for 1 revolution of the sun gear. Okay, this is given to you. So ns is equal to 1, np is equal to 5. Okay, if the arm rotates 2 revolutions about the fixed, in this case arm is fixed. Okay, if the arm rotates um, about the fixed sun gear, okay, then they are asking planet gear, the revolutions of the planet gear. So np minus na divided by ns minus na is equal to ts by tp. Okay, first of all, they have not given ts by tp. How to calculate it? Uh, this is like a if arm is fixed. So it becomes a simple gear train, right? And if I want to say ts by tp is equal to np by ns, which is sorry minus np by ns, which is minus 5. Okay, this is the answer. Now this I'll use information in the next formulation here. Minus np is something we have to calculate. N arm is speed of the arm is how much? Okay, arm rotates 2 revolutions. ns is 0. Sun gear is fixed. Arm is 2. Okay, is equal to minus 5. So minus 5 into minus 2 is tn. Okay, and tn plus 2 is 12. This implies np equal to 12. Okay, np equal to 12. Okay, NP equal to 12. Option C is correct in this case. Okay. Next question. Just a minute. So another question. A 20-degree full depth involute gear has involute gear has 16 teeth. Okay, and has a module of pi full stop. Its base circle radius is base circle radius is base circle radius is yeah, this is a question. Okay. Um, the options are like 3.84 millimeter less than the pitch circle radius, 3.84 more than the. Okay, let me write it down. The options: 3.84 millimeter less than pitch circle radius, RP. RP is pitch circle radius. Okay, less than the random circle radius, RD. Okay, this is C. Less than the RA and or 3.84 millimeter more than RD. Option D. More than RP. Okay, so RP is like your pitch circle radius and RD is dedendum circle radius. Okay, try to solve this one. Okay, try to solve this one. So what is R? R is equal to MT by 2. Okay, R is your pitch circle radius, that is MT by 2. Module is equal to what? See, module is equal to, module is equal to D by T. This implies diameter is equal to MT. This implies R is equal to MT by 2. Okay, so it is module is phi, number of pits are 16 divided by 2. It is 40 millimeter. Okay, 40 millimeter is your diameter. Now, RD is what? R minus 1.25 meter. This is 40 minus, sorry, 1.25 times module. So it is 1.25. Module is phi. It will be 33.75 millimeter. Okay, so this M is module here. Okay, 33.75. The radius of the base circle is equal to how much? you know it is r cos of phi, and that is 37.59 millimeter. You have the phi angle which is already given, and now if you compare base circle and addendum circle radius, it is 3.84. So the correct option is this one, that the base circle radius is a 3.84 mm more than the addendum circle radius in this case. Okay, 3.84 above the addendum circle. Okay, next is minimum number of teeth. Minimum number of teeth on a pinion to avoid interference when mating with a gear of any size with pressure angle the pressure angle 20 degree involute full depth tooth is. Options 18, 32, 62, and 2. Okay, try to solve this. Minimum number of teeth to avoid the interference in involute profile. Okay, we have solved a similar problem before. T minimum is equal to 2AR divided by sinus square phi. Okay, AR is what? What is phi? What is T minimum? Yes, okay, let me repeat that. If you remember, AR is your addendum. AR is our addendum, which is generally one module. Okay, phi is your pressure angle. Okay, and T minimum is minimum number of teeth. To avoid the interference. Okay, so with this formula, 2 times 1 divided by sinus square 20 will lead as 18 as the answer. Okay, minimum number of teeth on a pinion to avoid interference when mating with a gear of any size with a pressure angle 20 degrees. So yeah, since they are not given anything, let's consider the addendum. They are not specified anything. So let's keep it as 1 and you'll get as answer 18. Okay, another question again for homework, very simple, on a simple gear train. A simple A simple gear train shown below is driven by gear B. So lowest speed for the gear will be, okay, options are there: gear A, gear B, gear C, and gear D. Okay, somehow they are 40 teeth, 30 teeth. This is 15 teeth, 50 teeth. This is gear A, B, C, and D. Okay, try to solve this, and yeah, um, the correct answer in this case is option D. Okay, yeah, you can clearly see here it is with the most number of teeth likely to be having the lowest speed. But yeah, you can solve this and confirm. Okay, I'll proceed to the next slide. Okay, I'll proceed to the next slide. Okay, yes. Another question is yeah, I'll give one more question for you for the homework. Um, you can try. Little bit interesting. In a sun and planet gear train, okay, in a sun and planet gear train, fixed sun gear has 40 teeth and planet gear has 20 teeth. Uh, the full stop, the carrier rotates at carrier rotates at 10 radian per second and transmits a torque of transmits a torque of 5 Newton per meter. Stop. The holding torque on sun gear is this one is something you can try. The answer in this case is TS is equal to minus 3.33 Newton meter. Okay, first of all, you calculate the omega p. Okay, because what they have given, omega of carrier is given, sun gear is fixed, so omega p you can calculate. That you will get as 30 radian per second. And the next thing is by, I'll write a hint here, by assuming no losses in power transmission, Tp into Wp plus Ts into omega s plus Ta into omega a is equal to 0. Okay, or yeah, maybe you can yes, try to solve this. Or yeah, maybe we can just solve it now itself, since it is a bit different one. I'll give you another question for homework. You can try solving this. I have already given you the hint. So it's a planetary gear train, when it is a planetary gear train, either you write it as a ns minus na divided by np minus na, but it is equal to minus t number of tests on pinion divided by number or planet on the divided by number of tests on sun. Either you can write it like this, or if you write it in the form of omega, that is also correct, because in given question the values are given to you in the radian per second, not in rpm. So omega s minus omega a divided by omega p minus omega a is equal to minus tp by ts. If I write, it is also correct. Okay, so the fixed sun gear 0, arm is carrier, which is rotated at 10 radian per second. Omega p is something we have to calculate, minus 10. Number of hits on the planet are 20. Number of hits on the sun are 40. So this implies omega p is equal to 30 radian per second. Okay, omega p is 30 radian per second. So you got the omega t. So Tp into 30 plus T sun into omega sun is fixed plus Ta into omega A is 10 equal to 0. Okay. So first of all, this is one thing. So the carrier rotates at a torque of 5 Newton per meter. Okay. Sorry, carrier rotates at 10 radian per second and transmits the torque of 5 Newton per meter. So TA is also known to you, that is 5 into 10. So from this we'll get the TP is equal to minus 50 by 30 is minus 1.67 Newton meter. So this is your TP, not torque of the sun gear. Okay. One more formula you should know is total torque is 0. TP plus TS plus TA equal to 0. This implies minus 1.67 plus T sun. Because in this particular case, we are assuming sun is Z fixed. So that's why it's like omega is 0, but hence we are not able to calculate the TS. This term overall was gone. But as we know, overall torque has to be 0, assuming no losses. Okay, and then you will end up with a TS is equal to minus 3.33 Newton meter. Okay. So like this, you have to solve this problem. Okay. I'll go to the next slide. Solve the another one. A simple gear train. In a simple gear train. In a simple gear train, the gear on the input shaft has has 40 teeth. Intermediate gear has intermediate gear has 60 teeth, and one of the output shaft has 80 teeth. And one of the output shaft has 80 teeth. If the input shaft has 24 RPM, the input shaft has 24 RPM in counterclockwise direction. The velocity of the output shaft is okay. The velocity of the output shaft is. Try to solve this. You have to specify not only just the how much RPM it is, so and but also specify whether it's a clockwise or counterclockwise. Okay, so this is what you have to specify. So this is a simple gear train. Okay, input shaft has 40 number of teeth. Intermediate gear has 60 teeth. Okay, and the output shaft has 80 teeth. Okay, so this is given to you. If the input shaft has this is counterclockwise rotation, let's say, 24 RPM is the counterclockwise rotation. The velocity of the output shaft. So this is counterclockwise. This is clockwise. This is clockwise. This is counterclockwise. So the counterclockwise is the correct answer in this case, first of all. Okay. So the first part is counterclockwise. Now we have to figure it out how much RPM it is. N output divided by N input is equal to T input divided by T output. Okay. So N output is something we have to calculate. 24 into. You can directly eliminate this intermediate gears. Okay. Here, as you already know the RPM of this, directly you can relate input and output gear. Intermediate gears you can ignore in the simple gear train, and with that this problem becomes very simple. You can say it's 40 by 80 directly, and 12 RPM is the correct answer. So 12 RPM counterclockwise is the final answer in this case. Okay. Go to the another question. A pinion with 20-degree pressure angle, pinion with a 20-degree pressure angle, has 16 teeth. Sorry, 16 teeth, and has a module of of 5 millimeter. Full stop. It has full depth involute tooth profile. It has full depth involute tooth profile. Full stop. Calculate the non-involute profile. Calculate the non-involute profile on the tooth on radial basis. On radial basis. Options: 2.84 millimeter, 2.68 millimeter, 1.25 millimeter, 0.75 millimeter. Okay, so try to solve this. They have given a pinion with a 20-degree pressure angle phi. Okay, and has a module of 5 millimeter. It has full depth of involute tooth profile. Okay, so you can use the standard value of the addendum and the dedendum. Okay, considering the complete value of the addendum dedendum, you can proceed with the solution. So yes, What is your pitch circle radius? Pitch circle radius formula? You know, module is equal to d by t. So diameter is equal to module into t. So the radius will be equal to module into t by 2. Okay, we have talked about it. So 5 into 16. Number of pits are 16. Sorry, divided by 2. T millimeter. Okay, this is the first part. The question they're asking is the involute radial basis. Okay, non-involute portion is, the question here is non-involute profile. Non-involute portion is generally RB minus RD. Okay, in between the base circle and the um, dedendum circle. The difference between the RB and RD is your non-involute profile. Okay, so this is something they are asking. Sometimes they will ask you the difference between these two or comparison between RB and RD. We have solved one question, and here it is another way to solve it. Okay, the phrase is, the wording is different, but ultimately they are asking you the same question. So you got the R value. Next one is the dedendum radius. Is RD. Is R minus 1.25 times module. So it is 40 minus 1.25 times 5 is 33.75. And then base RB. This is your RD. Okay. Now the next one is base radius. Base circle radius is R cos of phi is 40 cos of 20. Okay. 40 into cos of 20 is 37.59 millimeter. Okay, and then you take the difference. 37.59 minus 33.75, 3.84 millimeter. Okay, question A is correct. We have solved a similar question before. Okay, but different wording. Okay, so remember, this is a very important part. Sorry. Calculate non-involute portion on the teeth. Okay, if this is something comes, do not panic. It's just a different way of saying the um, difference between the RB and the RD. Okay. Let me go to the next slide. We'll solve another question. Give me a minute. Let me check if I have any other question. Okay, let's take another question. Opinion with a pinion with 20 teeth is driven by a gear wheel having 100 teeth rotating at an angular velocity of rotating at an angular velocity of 5 radian per second. The pair have the pressure angle of 20 degree. The pair have pressure angle of 20 degree and module of 6 millimeter. Pitch line velocity in pitch line velocity in millimeter per second is okay. These are the options: 500,000, 1,500, 2,000. These are the answers, options. Try to solve this. Pitch line velocity they are asking. I'll let you know. What is pitch line velocity? R omega basically. Pitch line velocity is equal to R omega. That is your pitch circle radius into omega. Okay. Only thing is they have not given you the R value, which you have to calculate. Omega is already given to you. So what is the given data? Given data is omega, which is 5 radian per second. Number of teeth on the pinion is 20. The gear is 100 teeth. Okay. Pressure angle is 20 degree. So you know how to calculate the R. R is equal to what? Mt by 2. Okay. We are talking about the gear because 100 teeth rotating at an angular velocity of 5 radian per second. So this is your omega of gear, I would say. So R of the gear is equal to module into number of teeth on the gear divided by 2. Module is same. Module is in this case 6 millimeter. 6 into number of teeth on the gear are 100 divided by 2. It is 300. Okay, so use this information and now calculate the value of pitch line velocity. Okay, so if omega is known, the value of R is now also we have calculated. So the pitch line velocity is R times omega. Apply that and yes, calculate the answer. Sorry. So it will be 300 into 5, 1500 millimeter per second. Option C is correct. in this case. Okay. One last question we will take, little bit bigger question, and then we will end our session. Okay, let me write it. A rack and a pinion dry as following data. Okay, a pinion is 20 number of involute width, okay, 120 millimeter pitch circle diameter, okay. Addendum 6.25 millimeter, and rack also has addendum of course 6.25 millimeter. Okay. Question is, what is the least first question, what is the least pressure angle which can be used to avoid the interference? Can be used to avoid the interference. And the second question, with this pressure angle, okay, it's a link question. If you have calculated the pressure angle, with that pressure angle, find the minimum number of teeth in contact at a time. Find the minimum number of teeth in contact at a time is. Okay. So there are two questions. Okay, let's look into this. Number of teeth on the pinion is 20. The radius 60 millimeter, because 120 millimeter is the pitch circle diameter. Addendum is also given to you. You can, to avoid the interference, I would say, to avoid interference, addendum of rack, okay, this has to be less than the r sin square phi. Okay, so from this you can calculate the phi. Sin square phi should be greater than equal to 6.25 divided by 60, because yeah, r is 60, and from this you'll get phi has to be greater than equal to 18.83 degrees. So the first answer is 18.83. Okay, 18.83 for this. Second, with this pressure angle, find the minimum number of teeth in contact. To calculate the minimum number of teeth, you need basically a contact ratio. Contact ratio is like it tells you the minimum number of teeth in contact. Um, or you can also calculate it by using the. So what is this basically? It is arc of contact is equal to divided by the circular pitch pi d by t. Okay, circular pitch or arc of contact. What is circular pitch? Pi d by t. Okay. Mm, and arc of contact is nothing but the path of contact divided by cos of phi. So it's again you can say it as a path of contact divided by cos of phi to pi d by t. Okay, so you need only path of contact in this case to be first calculated, and then when you calculate you can put it into this formula and tell the answer. So the formula for path of contact, we already studied this if you remember, is under root of r t square minus r cos of phi whole square r square minus r cos of phi whole square plus addendum of rac divided by sin of phi minus r sin of phi. So Ra is equal to r plus addendum of opinion is 60 plus 6.25 is equal to 66.25. So now if you put it back into the equation number 1, path of contact is equal to, directly I'll write the formulation, you can do later, 34.8 plus first part will come as 34.8, second part will come as 18.27, and the last part is minus 20.52. Overall it will be 32.55. Okay, and then you put it on a equation number A. From A you will get it as contact ratio is equal to 1 point something, 1.8 something. Okay, so hence you can say the minimum number of pairs in contact is 1. If it is not more than it is not 2 point something. If it is 2 point something, then the answer will be 2, but it is 1 point something. So minimum number of teeth in contact is 1. Okay, so 1 tooth is the answer. Okay, so yeah, I think let's end our session. We have already exceeded 5 minutes. In the next session, we will study the some other topics such as the flywheels. Okay, and flywheel and governors. Then yeah, in the next session we'll have to study the gyroscopes and cams, problems on it, and the balancing as well. Okay, so we'll have 2 more sessions. One will be tomorrow and one will be on Sunday to cover these topics. Okay, so that's all for today. Thank you all for joining, and let's continue tomorrow. Thank you all. Bye. Good night. Thank you. Bye.